Bismillahirrahmanirrahim. How are you, students? Today we will study physics, chapter number 9, physical optics. Physical optics. Today topic is coherent sources. The sources which produce waves having the same frequency, equal or comparable amplitude, and a constant phase difference are called coherent sources. Two wave sources are perfectly coherent if they have a constant phase difference and the same frequency. Coherence is an ideal property of waves that enables interference. Coherent sources are those which emit light waves of same wavelength, frequency, and have a constant phase difference. So when two different waves, two different sources, when you get light from two different sources, when you get light from two different sources have a constant phase difference, having same frequency and wavelength, is called coherent sources. Laser is a coherent source. Incoherent led light, this is incoherent led light because different wavelength. Many wavelengths from a bulb, light is emitted with many wavelengths. Monochromatic laser is monochromatic, directional, and coherent. So laser is the best example. Coherent sources are the sources which have same frequency having zero phase difference or constant phase difference. Interference phenomena, the phenomena of redistribution of energy due to superposition of light waves by two coherent sources is called interference. For interference, first you must remember the source must be monochromatic. Same frequency and wavelength. Must travel in same direction. Travel in same direction. Constructive interference. In constructive interference, the amplitude of the resultant wave is greater than either the individual wave. When they interfere constructively, they reinforce each other. When two waves interfere and they reinforce each other is called constructive. And if they superpose each other, cancel the effect of each other, then it is called destructive interference. Condition for interference. To get sustained interference, light waves have to be satisfying the following condition. Condition for sustained or good interference pattern. We requires two monochromatic sources. We need two sources which emit monochromatic light. These two sources must be coherent. Phase difference is same. Constant phase difference. They have constant phase difference. The frequency must be same. The amplitude must be the same. Amplitude is same, frequency is same, have a constant phase difference, coherent, monochromatic. They must travel in the same direction. Direction is same. These two sources must be as near as possible, and the screen must be as far from them. They must travel in the same direction. Condition for interference. The two interfering waves should be coherent. wave should be coherent. The phase difference between them must remain constant with time. The two waves must have same frequency. If interfering waves are polarized, they must be in the state of polarization, in the same state of polarization. The separation between the light source should be small as possible. The distance of the screen from the source should be quite large. The amplitude of the interfering wave should be equal or at least very equal, nearly equal. The two sources must be narrower. The two sources should give monochromatic or nearly monochromatic or having constant phase difference. Now, for constructive interference, part difference must be integral multiple. For constructive interference, having constant phase difference. Having constant phase difference. For constructive interference, this is not the compulsory condition. The part difference must be integral multiple. Part difference must be integral multiple. Part difference n lambda, integral multiple. For structure interference, part difference must be half integral multiple, where n is equal to 0, 1, 2, 3. So if the part difference is integral multiple, then they will interfere constructively. If the part difference is half integral multiple, they will interfere destructively. Now comes towards Young double slit experiment. Young double slit experiment. This experiment verify the wave nature of light. This experiment verify wave nature of light. The principle of this experiment is based on the division of a wavefront to get phase coherence between the interfering light source. So the purpose is for interference. Monochromatic and same frequency. Monochromatic phase difference and frequency. We should two interfering light will be monochromatic, having constant phase difference or no phase difference, having same frequency. So the purpose is here light is coming. So we take sodium light, we take red light, blue light, any light. You can take any light. So when you take light, single light, red, blue, having single frequency, they will propagate here. Diffraction will take place at this point, and they will interfere. They will travel in the form of wave. Here, light there is a slit, and the second slit is here. So it will work a separate source, and this will work as a separate source. So when light come here, it travels in this direction, and it travel in this direction. Here interference will take place, and here also interference will take place. So you obtain, for example, this is light travel in this direction, So here the light will interfere, diffraction will take place. This will work as a slit 1, this is slit 2. This work as a separate source of light, and this will work as a separate source of light. When the light of this source and light of this source is of slit S1 and slit 2 interact, they will either interact constructively or destructively. So this is the separate source and this one is the separate source. Both are the separate sources of energy, but they have, we obtain these sources of light, this and this, from a single source. So phase difference will be same, frequency will be same, wavelength will be same. So there's a condition is satisfied that the sources must be coherent. Now we take a single point at this point, a single point here. Light is coming from this slit and light is also coming from this slit. A path difference is integral multiple. Path difference is integral multiple. Path difference is integral multiple. Constructive interference will take place. Constructive interference will take place. A path difference is half integral. Instead of integral, it is half integral. Then destructive interference will take place. Now we will consider a single point on a screen. For example, we take this point, point P. Light is coming from slit 1 and light is also coming from slit 2. So this path difference is R1, this path difference is R2, is 1P and is 2P. Let's say it's is 1P and is 2P. Is 1P minus is 2P. If this is the path difference, is 2P and is 1P. This is the path difference. If this path difference is integral multiple, for example it is 0, lambda, 2 lambda and so on, then constructive interference will take place at point P. If this path difference is half integral multiple, then destructive interference will take place. For example, we label this is point A, this is point B and this is point D. I will label again. Let's say this is point A, this is point A, this is point A, this is point B, this is point Q. BQ is the path difference. BQ is the path difference. If it, and path difference according to will be equal to, path difference will be equal to d sine theta. Is we take this angle, sine theta is equal to perpendicular by base, perpendicular by hypotenuse. So BQ divided by D. So BQ is equal to d sine theta. BQ is equal to d sine theta. Now for destructive interference, path difference is d sine theta. is equal to, if the part difference which is d sine theta in this case is lambda by 2, 3 lambda by 2, 5 lambda by 2, half integral multiple, then destructive interference will take place. Destructive interference will take place. For destructive interference, d sine theta is equal to n plus 1 by 2 lambda, n plus 1 by 2 lambda. Now position of fringes on the screen. As we know that this distance, this is B, this is A, this is Q, this distance is S, this distance is S, distance between B and Q is S, and this distance is equal to D. Now the next one is if you look to the diagram, S divided by Y, S divided by Y, this distance is Y. The ratio of, take this, compare this perpendicular, the ratio of perpendicular of this triangle, with, compare with this triangle, is S divided by Y. The ratio of perpendicular of two triangle will be equal to the ratio of hypotenuse of that triangle. We compare the two triangles A BQ and PO, triangle P, this is P, this is O, this is point O, this is point small q, POQ, yeah, OPQ. Now we know that Y is equal to PE divided by D multiplied by S. So in this case PE is equal to L, PE is equal to L, this is equal to L, PE is equal to L. So Y is equal to, in place of P we will write L D S, LSD. This is per bright fringe on the screen, per emit bright fringe. Y is equal to 0, L lambda divided by D, 2L lambda divided by D, 3 lambda L divided by D, and so on. So the general relation is M lambda L divided by D for bright fringe. For dark fringe we will write locate the position of emit dark fringe. The value of S for destructive interference is Ym is equal to m plus 1 by 2 lambda L divided by d, where m is equal to 0, 1, 2, 3. Lambda L divided by 2d. First dark range 3 lambda L divided by d. Second bright range 5 lambda L divided by d. Third bright range, and so on. Fringe spacing. Fringe spacing. Fringe spacing. Fringe spacing. The distance between two consecutive bright or the distance. Fringe spacing is the distance between bright fringe, bright fringe, two bright fringes, or two dark fringes, is equal to, take any two consecutive, two lambda L divided by d. This is the second fringe, this is the third fringe. You can take second, first and second also. You can take first and second also. So fringe spacing will be equal to lambda L divided by d. This is the fringe spacing, which is, we call it del y. Now this is the geometrical diagram. This is the labeling, and different expression is shown in this diagram. This is for the constructive, this equation is for destructive, for bright fringe and dark fringe. Look students to the given diagram. One light is traveling from this point to this point, to point P, and the second light is traveling through this path. This is the path difference. This path difference decide that constructive interference will take place at point P, or destructive interference will take place. Constructive or destructive interference will take place. Constructive or destructive. This path difference, we decide from this path difference. If path difference is integral multiple, then if path difference is integral multiple, then constructive interference will take place. If the path difference is half integral multiple, then destructive interference will take place. Coherent, we studied the coherent having same frequency, when two light waves, when light is emitted from two different sources having same amplitude, frequency and wavelength is called coherent sources. Thank you students. Wish you best of luck. Allah Hafiz.